Hey everybody, Mike here. I finally got my fully off-grid Starlink set up. Find out how I put it together and what it's for coming up. So for me, the most exciting thing about Starlink has always been the ability to connect to high-quality internet from anywhere in the world. Now, we can't do that from anywhere in the world just today, but this is the setup that's going to allow that once the network is fully built out and the ability to move your terminal is fully deployed. This is really my first go at a fully off-grid setup. There's definitely some things that aren't completely efficient and can definitely improve over time, but I wanted to give you an idea of how this setup is put together, and then take a look at some of the recent Starlink announcements to kind of get a feel for how this might evolve in the future. So why don't I dive right in and give you a look at the components that make up the off-grid setup. So I had a couple goals for the system when I started putting it together. First, it had to be very portable. I wanted to be able to pack it all up into a bag, something like this size, except for Dishy, of course, which is a little bit bigger, but all the other components had to be small, relatively lightweight, and something that I could kind of transport and toss in the car easily and just go somewhere. My thinking behind a bag like this is it's got all the equipment I need to power the Starlink dish off-grid, plus in the back it's got room for a laptop so that I can actually do some work using this off-grid setup. This bag here is actually a VanQuest bag. It's nice and rugged. I'll show you a little bit more details about that in a bit, but with that idea of that goal in mind, let's take a look at some of the actual equipment. Now, anytime I do a new setup with the Starlink dish, like anyone, I have to run a speed test to see how fast it is. So I just threw this on the ground and turned it on. You can see there's actually some trees in behind that probably do make an obstruction. But just to give you an idea, it's pretty sunny, but you can probably see that. 180 megabits per second down. The uplink is a little bit slower, 3.9 megabits per second. Probably because of the obstructions. I'll try moving it around later and running another test, but that's just to give you an idea of what we're talking about with this off-grid setup. One of the most important parts of the system is the solar panel. I wanted this to be an off-grid setup that would actually be able to run long-term. So even if I was out in the woods for many days on a camping trip or something like that, I'd be able to actually have a power source, if it's sunny, that I could use to charge up the system so that I could keep recharging it whenever I needed it. Now, this panel here is a 60-watt solar panel, and this is made by Power Film. And it's a pretty amazing solar panel because it is completely flexible, as you can see. So I've got it all laid out here, but it actually folds up just like this. And the whole thing folds flat to fit in my backpack. And then when you need it, you can just unroll it again. Unfold it. And you're harvesting the 60 watts of solar energy. So the Starlink user terminal actually uses more power than this panel can produce. At the AC mains level input to the power supply, the Dishy uses a little over 100, between like 100 and 140 watts of power. So for this setup, which I'll show you in a little bit, I'm actually using an inverter to go from the 12 volts from the panel and the battery up to AC. And then the AC power is being converted by the Starlink power supply back down to the voltage it uses over its Ethernet cable. So that's not super efficient, but it works for now. But the main thing is this panel is not big enough to provide that power continuously. So it will help, it'll charge the battery a little bit, but while the Starlink dish is on, it's actually depleting the battery, so it won't last forever. But the idea with this setup is I can power it on, use the internet when I need it for quite a while, power it off, but leave the solar panel out so it tops the battery back up again. So that way you can't use it continuously, but it's available when you need it and you've got reasonable run time. I'll talk about the battery in a little bit, but it gives you roughly a few hours of typical usage. This panel here, made by PowerFilm, they actually do make bigger panels. So you can get double the size for 120 watts, and it goes even bigger beyond that. So you could get a bigger one and actually power it continuously. 100, anytime there's daylight, you're running the Starlink dish would be fine. But these panels are pretty awesome in that they're so portable and so rugged, but they are pretty expensive. So I thought I would start with the 60 watt panel, and then if it works out great, maybe I'll add a second one or upgrade to one of the larger panels. So the rest of the components are here. And what I'll do is I'll trace the power from the solar panel over there through the system all the way to the Starlink dish. So coming off the solar panel, and I bought an extension cord so the solar panel can be a little bit further away, we've got this unit here, which is the Jenison charge controller. So this is what takes the kind of unregulated variable voltage from the solar panel, and it converts it to the charging voltage required by my battery here. And this is a particular charge controller for supporting this battery type, lithium iron phosphate. This is sized to support the power that comes out of this 60 watt panel. So it's a 5 amp charge controller. The same company, Jenison, makes bigger controllers for bigger solar panels, but I picked the one that would match my panel exactly. So it's got enough capacity to handle everything from this panel with a little bit extra just in case. So from the charge controller, the power goes out into my battery. And this battery is a lithium iron phosphate battery made by Bioenno, and this is 30 amp hours at 12 volts, or 360 watt hours capacity. These come in many different sizes, different capacities. This one I chose because it was small enough that I could actually fit it in the backpack and carry it around. It's not too heavy, but it's definitely not light. But it's big enough that it can power the next step, my inverter, and it's got enough capacity that it can power Dishy for a reasonable amount of time. And I ballparked this at a couple hours. So the next stage out of the battery, there's a second set of leads, a bit thicker, which come out and run to my inverter. Now this inverter is 400 watts. Like I said earlier, the Starlink system only uses, let's say, less than 150 watts. So this has plenty of capacity. This is actually a pure sine wave inverter. Now I've seen reports that the Starlink terminal will work with a modified sine wave inverter. So I actually started with this smaller unit here, Semlex, a 250 watt modified sine wave inverter. And it actually didn't work. It didn't even power on the power supply, no lights. So I'll show you a zoomed in view here, but there are at least 2 different models of power supplies. And I've seen reports that one supports running off an inverter and the other one doesn't really work that well with inverters. This one definitely does work with the pure sine wave inverter. That's what I'm using now, but it does not work with this modified sine wave inverter. So the job of the inverter is to take the 12 volts from my battery and convert it to alternating current, the AC voltage, like in your household wiring, at the output here. And now this comes straight over to the Starlink power supply, just as if you plugged it into the wall. Now this works fine, but it's not very efficient because you're taking a DC voltage from the battery at 12 volts, converting it through this big guy to alternating current, and there's some efficiency losses doing that. And then into this unit, which converts it back down to DC at a higher voltage, but back to DC. So there's some efficiency losses there. And then from here out to the router and the Starlink dish. So ideally in the future, and I'm hoping this comes with some of these new mobile terminals, which I'll talk about in a second, they will produce a power supply that converts directly from 12 volts, say in a vehicle power supply, and boosts the voltage up to what the Ethernet cable needs for the Starlink terminal. That would definitely be more efficient than this setup, but this setup works and I haven't had to take apart the power supply yet. And then from the power supply, you know where it goes from there, just like all the other Starlink setups. We've got the black wire, which goes straight out to the Dishy, the Starlink user terminal, and the white wire, which goes to my Wi-Fi router here. So that's my setup that I've got right now. So like I said, end to end, this battery has enough power in it when it's fully charged to run the whole setup for around a couple hours. With the solar panel, I've now got the capacity of charging the battery, or at least keeping it from depleting as fast while the system is on. And when the system is off, if I just turn it off, the solar panel is still running and it's still charging the battery, so it will bring it back up to full capacity. And then when I need the internet again, I can just power on the system, power on the inverter. The Starlink terminal will research, find the satellite, and then my internet will be back up and running again. So I am off grid with this setup, but I am still within my service address cell. So Starlink does not yet support actually being mobile with the Starlink user terminal. It's registered to a fixed address, and that's where service is provided. Now, they have recently updated their user interface in the support webpage, where you can actually go in and request to move your service address to a new location without having to actually contact support. So this is an enhancement that if you're going somewhere, say for a longer time, and I'm thinking of the use case of maybe you're at your home address during the winter and then you move to a cottage or cabin in the summer, that seems like it's within the allowable. You could request a change twice a year, say. I don't know if they'd get upset if you tried to change your service address every weekend, but I'm actually going to try some experiments with that in future videos, so stay tuned to that. And actually on that note, if you like this kind of stuff, leave a comment down below if you're interested in this off-grid style setup. Click like button, it really helps the channel grow, and subscribe if you want to get access to all my new videos as they come out. And of course, the other big announcement is Starlink has recently filed for permission from the FCC to run user terminals in motion, or Earth Station in Motion, ESIM. And this is actually mounting something like these Starlink user terminals on a moving vehicle, like an airplane, a boat, or a truck, or a car, or something like that. With the idea that not that you can use it at one end or the other, but actually that it would be continuous coverage while the vehicle is in motion. So for airplanes, this definitely fits the use case of, Wi-Fi on board an airplane. For boats, a cruise ship, being able to get high-speed internet would be awesome for anyone on the cruise ship. But the thing that's kind of new and really different is this idea from a smaller moving vehicle, like a car or a truck. Now, Elon Musk has tweeted that this is not going to be for adding Starlink to Teslas. He said it's far too big to fit on the vehicle. Now, I don't know if that's a concern specifically for Teslas, where they've got nice glass roof. There's not really a lot of place to put that user terminal without, not having that glass roof in the car, basically. But, I mean, it would definitely fit on a car, so I'm interested to see if that's going to be an option going forward. Another interesting thing is from the FCC application, they say that the user terminal for these eSIM systems is going to be electrically identical to these systems. So it might actually be that same circular disc, just mounted in like a more flush surface mount on, say, the top of an airplane or the top of a truck. Either way they do it, it would be very cool. I'm particularly interested if, once they have more satellites up in the sky, if they can get rid of the motorized base. For my off-grid setup here, it would be slightly more compact if the Starlink user terminal was just a flat disc that I could just drop onto the ground, and it would entirely use the phased array steering to find satellites. That would mean I wouldn't need the tripod base, and I wouldn't need the pole, and I wouldn't need any of the motors or gears, which would significantly make this a lot lighter and easier to transport. Still pretty big around, but not nearly as big as the tripod. So I'm definitely going to be doing a lot with my off-grid setup in upcoming videos. So definitely subscribe if you want to see those videos when I release them. I'm really interested to see how it works in a real kind of a camping setup where it's used in the daytime and at nighttime, see how the solar panel performs. I want to actually do some timing to see how long a setup like this actually lasts with, typical usage, so that I can maybe adjust the sizing of some components, make it a bit lighter or a bit powerful where required. I want to also experiment with actually carrying it around on my back for a long distance, just to see, is it too heavy? Is it light enough to actually work? And really just experimenting with it to try to make it better. I'm also really interested in using this off-grid setup to do a live stream to all of you, so that you can watch me in real time through Starlink to space, back down again, HD quality video from the middle of nowhere, solar panels, Starlink user terminal. It's going to be awesome. So definitely stay tuned for that. I want to thank you all for watching. See you next time.